Oh, hey, Phil.
Good morning, Phil Marshall here. We're going to be waiting for all the attendees to get in. Should only be a few minutes, so I'll let you know when we're ready to go. All right, so good morning and welcome to our webinar on BIM for building product manufacturers. My name's Phil Marshall, and this webinar is one in the series offered by MicroCAD on the use of AutoCAD's Autodesk's tools and data platform to enable manufacturers to collaborate with architects, builders, and other partners in the building project. Our next webinar will be May 20th when we look at the technical details of sharing data. As a company, MicroCAD empowers design professionals in the construction and manufacturing industries to increase productivity and meet project goals. With 30 years of experience as a minority-owned business, we pride ourselves on working with clients through every stage of the design process to assess needs and provide tailored and effective solutions. Today, we're focusing on the functionality and workflow supporting design collaboration. Design collaboration is where multiple people can participate in the design process and share information synchronously. This is clearly where the biggest benefits of BIM are. Autodesk has taken this concept and put it on the cloud. This webinar is intended to give you an understanding of how building product manufacturers can share data with architects. We will show 3 different workflows for different situations and illustrate how the Autodesk tools are used. The Autodesk product highlight here is Inventor, a full-function CAD/CAM system for product design and manufacturing. We will show the interoperability with Revit, an architectural BIM modeling system. As we go through this webinar, you may have questions or comments. Feel free to enter them into the chat area of the interface on the right-hand side. If you don't see the control panel, click on the orange arrow. I will try to respond as I see the questions. One other point, the excitement of BIM extends to all the partners in the building project. This webinar focuses in on the manufacturers, but everyone benefits. We will offer other BIM 360 webinars in the future and expand them to include all of the potential users. But the intended audience for this webinar are the building product manufacturers. That's you. This applies to both vertical and horizontal construction endeavors, architectural, civil, plants, engineering. Projects are getting more complicated, and the use of modular design is increasing. More and more building products are being made in the factory environment and not at the job site. And the project team is more and more using BIM, or Building Information Management, to collaborate. So what does this mean to you? The architect may have one idea of, say, a building system, a railing system should look like for his building. He would then search catalogs for a matching railing. If there is a close match but not exact, the architect defines his unique requirements and loads them into his BIM model. The manufacturer of the railing system would consider the architect's unique requirements and cost out the custom products. They would then have to plan the manufacturing processes and raw materials for that product. They may add information to the BIM model reflecting their processes. When the finished railing gets to the job site, the construction worker needs to install it using the information from both the architect and the manufacturer. Where do they get that data? The BIM model. What's the common thread here? It's the data. Each of the partners in the project needs information from the others and generates more information internally, but each cares about different things. The architect is concerned about how it looks. The manufacturer is concerned about the details of how it's built. The construction team is concerned about how it's attached. And each uses a different tool. The architect probably uses Revit. The manufacturer uses some mechanical design software like SolidWorks, CATIA, Creo, or Autodesk's own Inventor. And the contractor just wants to look at the model and the drawings. In the past, paper drawings were used to exchange this data, but this is a slow, incomplete, error-prone approach. With BIM, all partners can use 3D intelligent models, but we have to provide interoperability amongst all the players. What we're talking about today is how the manufacturer can easily make the data from the architect's BIM model available to their internal CAD/CAM systems, and just as importantly, handle the inevitable changes. Let's look at an example. Here, the architect working in Revit has a design for the building. He wants to add balconies for the doors on the 2nd and 3rd floor. He brings into his BIM model a balcony component, perhaps downloaded from a manufacturer. Then he edits it to fit his particular building, making it 2 instead of 3 balconies and aligning it to the doors. The manufacturer working in Inventor would see the architect's changes and apply them to the product assembly. Note that the manufacturer's model is much more detailed than the architect's. This is because the manufacturer has to have everything needed to make the product, while the architect only needs the parts for visualization. The manufacturer may make some further changes, maybe because of the engineering calculation or to reduce cost. The manufacturing model is simplified and passed back to Revit as a Revit family for the architect to review. This bidirectional flow of data could continue in design iterations until both partners are satisfied with the design. So what kind of building products are we talking about here? There's a large number of things like stairs, escalators, elevators, conveyors, window and window systems, doors, precast concrete, pre-stressed concrete items, metal or wood framed wall panels, curtain wall systems, wall cladding, both interior and exterior, sunshades, and so on. More and more of the final building is fabricated off-site and delivered as a module, and each of these products has the same data sharing requirements. Okay, so how can you actually share the data? There are three potential workflows depending on the type of products you make. One, if you're making standard parts, taking advantage of manufacturing efficiencies of scale, then you would publish a catalog and have the architect select products from the catalog. Your design and manufacturing processes don't need any input from the architect. Two, if you are primarily making configurable products, that is, standard components that can be combined or altered in some way, then you need to work with the architects on the particular configuration they need. Starting from your standard assemblies, they might introduce minor design changes to meet the project requirements. This is a lot of back and forth data exchange. Three, if you are delivering custom products defined by the architect, then the source of the design is the architect, and your job is to determine the manufacturing process. Of course, a good architect would always be open to suggestions to improve the product or to make it less expensive to manufacture. Therefore, some interaction and bidirectional data flow is necessary. The standard component or catalog workflow is the easiest workflow. The manufacturer designs a component in their favorite 3D design software. Of course, we'd like to think it'd be best if it were Inventor, but even if it isn't Inventor, Inventor can use associative links to the other mechanical CAD systems. CAM output could come from this design either from the original data system or from Inventor. In Inventor, the model can be simplified because the architect doesn't need or want excessive detail, and defining parameters can be added. This is then output and published as a Revit family to make it easy for the architect to use. These Revit families can be included in an online catalog. Here, there isn't a data flow from the architect, that is solely from the manufacturer to the architect. The configurable products workflow is the most complex workflow. Here we repeat what we covered in the catalog workflow. The manufacturer designs the product, simplifies and parameterizes it, and uses Inventor to publish a catalog of standard Revit families. But now the architects get involved. They take your designs and modify the requirements, either by changing your Revit families or creating their own. You then have to incorporate their changes into your model. With Inventor, that is easy. Inventor can link the Revit model into the product design and let the product designer work with the architect's geometry. Because it's an associative link, if the Revit model changes, the Inventor model will change also. And this is a closed loop. Your updated Inventor model can become a new Revit family, which can update the family in the architect's Revit model. This way, everyone sees the most recent data. The custom products workflow is where the architect designs the product and you just figure out how to make it. Using Revit, the architect builds a geometry, perhaps making a Revit family. This geometry is linked into the Inventor model and further detailing can be done. Manufacturing methods are decided and optimized. You then have the option to modify the geometry provided by the architect to improve performance or reduce costs. These changes could go back to the architect using Revit families. usually of a simplified model, and we iterate as needed. Again, everybody gets to see the most current data. So why have I been stressing Inventor? Because only Inventor provides out-of-the-box functionality that fits so well in the building product and fabrication workflows with BIM and Revit. Models built in Inventor can be transformed into Revit families for architects' use. The Inventor models can contain the intelligence to let these families be used by Revit's analysis tools. The models become part of the building BIM model, usable by everybody on the project. Inventor can link to Revit models. The geometry created by the architect can be part of the Inventor model, and it updates automatically when the architect updates the Revit model. And this intelligent model can include additional data for asset control and facility management. Any design created in any CAD/CAM system, 3D CAD/CAM system, is usable by Revit. If not Inventor ready, you can simply link to the native design file. Typically, then you would simplify the model because the architect doesn't need the same level of detail you need, parameterize it, and output a Revit family. An Inventor model can link to a Revit model. The product designer can make sure the product meets the form, fit, and function requirements set by the architect, and the product design can be echoed back to the architect as a Revit family for review and approval. Inventor fits in the BIM world because the manufacturer can build libraries of their components as Revit families and make them available to the architects for downloading. Let's look at another example.
In the construction industry, custom fabricators like you want to provide additional value to your company and your customers by getting involved with building information modeling. In Inventor 2021, we've improved the interoperability between Revit and Inventor by maintaining an associative link to the inserted Revit data as you work. The Revit project can be accessed from a local file or coordinated via the cloud using Autodesk BIM 360 Common Data Environment. On referencing a Revit file, custom views from the Revit project can be selected in Inventor, allowing you to filter the BIM to just the information you need. In the Inventor browser, the Revit model is organized by category, allowing you to further examine the structure of the model and filter the BIM to your requirements. Once placed into your Inventor assembly, the Revit project can be used as a reference model to help guide your design. Working with the native Revit project helps you locate your design using shared coordinates, size your design appropriately, and coordinate your design against the integrated BIM. Changes during the design process are inevitable. When the Revit model changes, we'll need to update the Inventor model to suit. Because the Revit model is referenced into your Inventor assembly without file translation, any changes to the Revit project will also update inside the Inventor assembly. A change to a design in Inventor is a change everywhere your design has been referenced, automatically updating all downstream uses of your design model, helping you coordinate your work and keep up with change. When your design is ready, you can output your model from Inventor as a BIM object, ready to submit, closing the loop on your design cycle. Autodesk Inventor 2021 extends any CAD functionality to help manufacturers in the construction industry collaborate and coordinate on BIM projects.
So we see that Autodesk provides the workflows to exchange data amongst all the partners on the project. But what makes this particularly useful now is that all of the products support intelligent information in the cloud infrastructure provided by Autodesk, the BIM 360 platform. This is especially important now that designers are working from home. Revit users can design with their models in the cloud, securely sharing the data with whomever they wish. Inventor users can access the same data, incorporating it into their designs. On the BIM 360 data platform, the software keeps track of all versions of all designs and controls access. All users can view, markup, create, or respond to issues, all without having either Inventor or Revit on their computer. And the access is using any device, laptop, tablet, or phone, and anywhere there is an internet connection. Single data platform for data, BIM 360. World's top software tool for BIM, Revit. World-class manufacturing and mechanical design package, Inventor, all from Autodesk and MicroCAD. Before I catch up on the questions, let me mention that MicroCAD will be running more webinars about BIM and cloud services. Take this opportunity to tell us what topics you would be most interested in by entering them in the chat box. We really want to address your needs. So let's see what questions have come up. Yeah, this is a good question. The point is that the Revit model typically in the building project is huge. And you don't want to burden the Inventor with all of it. That's a good point. Absolutely, Revit models tend to be very large, 400, 600, 800 megabytes, gigabytes. Large projects get to be extremely large, but we don't want to get all that data in. So what happens is in the Revit side, you select what views you want of all of that data, and then only the objects that are in that view are what comes into Inventor. So Inventor can control how much of that Revit data comes in and only the relevant stuff. If you were doing a sunshade over some windows, you would include the windows and probably the wall and the sunshade elements, but that would be it. And just that would be used by Inventor to do your design of the sunshade. We have a question about, we use AutoCAD now. Yeah, there's a lot of people who are using AutoCAD, especially for their manufacturing processes and linking to the shop drawings and fabrication drawings. You can continue doing that process. All you need to do is put Inventor into the stream, so the Inventor is used as your data center for all of this design work. You can create the drawings in Inventor and then output them to AutoCAD in AutoCAD format, and then you can go into your CAM system from there. So that fits in very nicely. Let's see what other questions we have. Yeah, somebody said that this looks really complicated, and it may look complicated because we actually showed 3 different possibilities. We showed catalog products, configured products, and custom products. And the reality is that you're typically in one business or another, so you wouldn't need to have all of those workflows. You typically focus in on just one workflow. And the other thing is that today we just showed an overview of the workflows without getting into the nitty-gritty detail. Next week we'll be doing that as another webinar, and that might make it a bit clearer on exactly what needs to be done and how it's done. Let's see what more questions we have. Yeah, so somebody pointed out that they don't want to share intellectual property, that sometimes in their design work they've added their own knowledge that they don't want the architect to have. Well, that's perfectly fine, because in Inventor you have the ability to not share certain information into the Revit family. So when you build your Revit family to go back to the architect, you would simply exclude the information and the parts that are your own IP that you don't want to share. And again, we'll see that next week when we do that webinar and the details. I'll give it another minute for some more questions. Don't see any more coming in. Okay, so I want to thank you for taking the time today to attend today's webinar. I hope you found it useful. We will be continuing the series of BIM webinars and adding new topics. Next week, we will get into the technical details of the data exchange workflow we talked about today. Please come and join us to get some more details about how this all works. We will have additional webinars in the BIM 360 platform outside the building products area. Keep watching www.microcad3d.com as we add more webinars to this series. If you want more information, feel free to contact me directly or any of the MicroCAD offices. We would love to talk with each of you and discuss how the tools we showed today could improve your productivity and smooth your workflows in the BIM project. Thank you again, and this ends the webinar.